Hello, everybody. Oh, welcome to choosing how your game animation feels. I am Patty Walker, the Technical Product Director for Runtime and Gameplay Animation, and you?
I'm Keith Yerricks, Senior Animation Programmer for Gameplay Animation.
Ooh, we almost said it wrong. You were close. And we are going to talk about a marvelous tool, not new, but production ready in 5.5, called Choosers. And it's going to change your world. Right, Keith?
Yes, definitely going to change your world.
Exactly. So, before we go into that, and that is the main portion of this, and then I sprinkled some other things because we've got like 30 minutes worth of content in a 60-minute time. We're going to talk, obviously, about Choosers first, right?
Yes.
Yep. Then I'm going to go into a little bit of some other new features for 5.5 with gameplay animation. Then we're going to talk about the gameplay animation sample and some of the things that we've added for 5.5 for that. And then I'm going to talk a little bit about what we're looking at in the future. So, with that, we're going to talk about your sexy if-then statement.
All right, so Choosers. We're feeling lucky, so we decided to do, we decided to do a live demo. So what I'm going to start off with is a little bit of motivation about why you might want Choosers. And to show that off, what I've got here is a little example of a very simple animation setup that's just playing damage reactions. So I've got some sliders. I can set the damage strength. Actually, before I go any further, I'm gonna open the rewind debugger because we forgot to open that earlier.
Getting too close.
And we'll record just so that it's going to help me find the assets that are playing later. So yeah, this setup has a couple different inputs. We've got direction, so we've got some left reacts, right reacts, we've got some from behind, and we got the damage strength. We've got medium, hard, light, and then I've got a set of animations that are deaths. They're not really death animations, but they're just kind of heavier animations from a couple different directions as well. And so I'm gonna start by jumping in and, did this start recording? There we go. I'm gonna jump in and show you how this is set up if you didn't have Choosers. So imagine you wanted to set up a system like this. You've just started using Unreal and you're using Animation Blueprint. You don't have any programmers. What we've got is a little state machine that's just got an idle and a damage reaction node. In the damage reaction node, I've got a sequence player. I'm using a feature here that not a lot of people might be familiar with, so I'll just explain that. This is called anim node functions. This onBecomeRelevant function gets called every time the sequence player becomes relevant. So every time it branches into this state, it calls this onBecomeRelevant function. We've used that for a lot of things. But selecting an animation is a good example where you want to change which sequence is played by that sequence player. So this is that function, which is calling setSequence on the sequence player node to change which sequence it's going to play. And it's using this blueprint function to decide what's a good damage reaction to choose for the particular inputs we have set. So this is already looking pretty ominous. I'm gonna zoom in.
Bleak.
So the first thing it's doing is checking, was it a death or not a death? So it's not a death, so we can follow it over here. Then it's doing some direction checks. This one's for the forward check, is checking if the absolute value of the angle is less than 45. And then we've got a left direction check. It passes the left direction check. And then we go over here and we're doing a switch on the damage strength enum. And it was a medium. So then we end up over here in the left medium section. And Then it's going to pick randomly from an array of sequences that I've set up on the animation blueprint. We don't really have a big set of animations here, so most of these arrays have just one thing in them, but I wanted to make it simple, so if somebody came and created a bunch more animations, you could just add something to this left medium array, and then it would randomly select that along with this one animation that it's playing. However, can you imagine maybe somebody creates a new 45-degree angle direction. You'd end up back here, you know, updating this math that's checking the directions. You'd be rewiring this whole graph for maybe an hour. So basically, this is not really a sustainable solution. I don't know if anybody's really doing content like this in their games. Most people, if they ran into this problem, would ask a programmer on their team to build them a system that just does damage reactions. And we were seeing a lot of teams using data tables for this particular use case. So what we've built is a new system, and what I'm going to do, I might as well stop Pi for the moment. What I'm going to do is rebuild that exact setup, but live and using choosers. And hopefully it's going to be a lot cleaner, and you'll be able to see all the animations that it could select from in one page. So choosers are an asset that's called chooser table. We're going to create a chooser table, and then I've got a couple different preset types that you can choose from. The animation chooser preset sets everything up for use with the chooser player animgraph node, and all it makes you choose, or all you have to enter as the input for this is your anim class. And now that anim class that I choose is, or that I've entered here as my for my animation chooser initialization, is going to be used to read variables like the damage direction, etc. So I'm going to hop into my new chooser. My new chooser table is empty, but it is a table, and in a chooser table, each row is a result that you might want to select. So what I'm going to do is I'm going to select all the animations, all my damage reaction animations. I'm just going to drag them and drop them into my chooser table. So now I've got a chooser with every animation in it as a row, and the columns in a chooser table then perform operations. Now, the main operation that we're typically thinking of for selection is these filter columns. So we've got a bunch of different kinds of ways to filter results based on different kinds of input. It's easiest to explain if I just start with an example. So I'll create a bool column. Now this column is going to take an input value that's coming off my animation blueprint. I'm going to read this isDeath bool. And then for each row, I can decide whether or not this row passes or fails if the bool is false, true, or for any value, it'll pass. So what I'm going to do is I'm going to select all the death animations, and I'm going to make it so they all pass when isDeath is true. I can edit these values straight in the table, but also I can edit over in the details panel, and that's very helpful for multi-select, multi-edit. I'll set these ones to only pass if isDeath is false. So we've got our death versus non-death already taken care of. Then I'm going to add an enum column, and this type of enum column will pass, will let you filter for multiple enum values for a particular row. So I can make a row pass for either light or heavy. So I'm going to bind the damage strength variable, basically the same kind of setup. I'm going to select every row and add an enum value there. So by default, I've got them all set to pass for damage strength light. I didn't actually care about these deaths. So death,
One more.
the
Oh, that's loud. Sorry.
oh, I missed one. So the death states here don't really care what the enum, the damage strength is. So I can leave those ones set to any. Then the rest of them I'm going to go through and I'll just edit them in the table. So I've got the back, for the back and the left and right cases here in my animation set, I don't have hard animations, I only have medium. So I'm going to make it so that for hard and medium, it picks the back medium 01, and then the same setup here for left medium. And then there's a front heavy, and there's a front medium somewhere, which I've lost. There it is. So that's pretty much all the setup we need to do for the enum, or for the damage strength column. And then the third thing that we were filtering on was the direction. So for that, we have these filter columns. They all work kind of in this way. Either a row passes or it fails based on some conditions. And you can compare gameplay tags. You can compare an object's class. You can check a bool. We have this float range one that we could use for this case, but there's a slightly more convenient one that is a bit newer. It's called float difference. And this is a different type of column that is called a scoring column. And scoring columns, instead of filtering, they produce a score value for each cell, and then whichever row has the highest, or the lowest error is selected. So there's a couple properties I need to set up on this float difference. First, I'll bind the damage direction float, and then in here, I'm going to set max distance to 180. That's used for basically for normalizing the score. And I know that the furthest away the input value can be is going to be 180 because it's an angle value. And then I'm also going to set wrap input. And that together with this min and max makes it behave like an angle where 180 and negative 180 are considered equivalent. And then we'll do the same kind of multi-select setup. We'll leave all the forward ones set to 0, and I can go through and select back, all the back ones. That's all. And set those ones to 180. And then I'm gonna go select the left ones. Oh, here. And set those ones to -90. And then the right ones. Sorry, I've got some screen scale here that makes it a little difficult. Select the right ones. Set those ones to 90. And then there's one last thing that I want to do, which is that randomization that you saw in the blueprint setup. So there's a randomization column, pretty much by default is going to take care of it as well as Blueprint does. There's some settings in there though if you want to prevent, for example, picking the same damage reaction twice in a row. There's a property on here that's called repeat probability multiplier. If you set that to 0, and if you bind a randomization context struct here, it's going to use that struct as sort of state to remember which one it chose last time and try to avoid choosing it again. That's only going to happen if you're in a situation where there's multiple options, like such as for the front light reactions, there's several choices. So that's pretty much all we have to do to set that up.
Hey, Keith.
Yes.
What was that one for?
Which one?
The number one.
Oh, sorry. Yeah.
Yeah,
I didn't explain that. The value that you get to set. Sorry, I should have explained that. This value here in the randomization column. If I, for example, want like my front light 1 here, if I want this one to be twice as likely as all the other front light hit reacts to be chosen, I can put 2 in there. So this is just a weighting or a probability. It doesn't need to be normalized or anything by you. The system will select, or when, for example, these 4 front light values are valid for a particular angle angle and damage strength and death value, it will normalize these for you and then use that as a probability of selection. In the case of the scoring columns, the randomized column randomizes between results that have equal score, and I believe there's a property on here, this equal cost threshold, so it uses this to decide if the score coming out of the float difference column is considered equal. So that's pretty much it. And then we need to open our blueprint back up. And on the animation side, all we really need to do is replace the sequence player with the chooser player. And then on the chooser player, we're going to use an evaluate chooser type and select our demo chooser we just made. And that should be it. We'll hit compile, and it didn't work. What did I do wrong? This is the magic of live demos. Let's open this up and make sure I did everything right. Damage direction bound. It's not the saving it. Don't worry. I guarantee you that. Something didn't come. Let's play here. All right. I take it back. It worked fine. Sorry for panicking, everyone. It was a close call. Let me open this blueprint.
I was freaking out internally.
I'm not sure. Oh, what happened here was just that it was attached to the character in the world, and that character wasn't actually it was getting data from Rewind Debugger, is what the pose was showing here. So the pose didn't show properly. But now what we're seeing is the same setup. It's coming in here. It's playing the chooser player, and I will. We're recording. Start recording again. Some of these workflows are a little nicer to use on 2 monitors, unfortunately. But what you see here now is it's doing the same thing it was before. It's for the front direction, light enum, not death. It's randomly picking between front light reactions, except sometimes it's playing a front medium reaction. Maybe there's a bug. So you'll see this extra row that's called this chooser evaluation section in Rewind Debugger. If I open it up, we can see what's being selected, and let me scroll over here. You see each cell is being colorized based on what the value it was, what value the input was, and the value of the cell. And then you can see this arrow is showing which thing is being selected. So if it's thought I saw it selecting a front medium. That one. Why is it picking that one? Well, it's because I set it up wrong. So there, it's fixed. Yeah, because I thought there was only one front medium, but there's actually 2. So there you go, live debugging. The other thing you can see, let me try this like that for a moment. This is all integrated with Rewind Debugger, so I guess I have to do something interesting for it to show something interesting. If I go in here and, for example, make death true for a moment, and I pause, I can scrub back to the evaluations where death was false, and it should live update. Are we scrubbing? Oh my goodness, sorry. go. Open that chooser again. There we go. You can see these guys switching back. You should be able to see this guy switching back to the value that was where. Here's where we're playing deaths, and here's where we're playing non-deaths. So when I scrub across these, it should be switching to showing, yeah, there we go. So when you scrub to the exact frame that an evaluation occurs on, it should update here to show that the true values failed because death is false. And then when we scrub to a frame where it was true, where death was true, then you see your debugger updating with those values. So that's pretty much it for this example. I'm going to go over a couple of other features that we have just in some pre-set up choosers here. One other feature we've got is called auto-populate. So I've pre-set up this chooser with a float difference column that has an auto-populator on it. And auto-populators are a class you can implement either in Blueprint or in code that gets to read the result asset and then compute a value for the cell. So I've got these animations, and the auto-populator that I have basically computes the speed the animation's moving at. And so when I drop it in, it automatically puts 0 for the idle and a whatever 530 centimeters per second for the run and something else for the walk. So that's auto-populators that are new in this release. And then, go back, we have nested choosers. Nested choosers were in the last release, but they were pretty rough. What nested choosers are is basically an embedded chooser table that will evaluate if its row is the one that passed the top level chooser or whatever. You can nest these as deeply as you feel like, but basically this is the same setup as the one that I just showed, except for I've separated my reactions into the deaths, which are here, and they just have a direction column and randomization, and then the reactions. And then in the root chooser table, we're just using a bool to choose between these nested choosers. Now you can create a nested chooser by adding a row of the nested chooser type, and then you can select an existing nested chooser, or you create a new one, whatever. And then when you pop in there, you've got this one's nested inside the reaction table. So that's nested choosers. You can also use the evaluate chooser result type, which will let you refer to another chooser table asset. The difference being that the nested choosers are embedded in this asset, and if you're using evaluate chooser, it looks things up in another chooser table. If you've got really large sets, that might be nicer for breaking up your data so that multiple people can edit at the same time. But we found a lot of Unreal users don't like having a whole bunch of assets. So the nested chooser table was, for people who don't want to create 5 assets for their damage reaction setup. Instead, you can create 1, but it behaves like as though you had 5. I feel like I had a couple other things.
You did. You did.
My list.
Yeah, so non-animation. Trees, potentially. Could we choose between trees?
Yes, I do have a couple things. Oh yeah, this one is of interest to everyone, I'm sure. Let me just open up the demo chooser. No, let me not open up that one. I'll do it in here. One of the types of columns that I didn't mention is output columns. So an output column, the way it acts is if a particular row was selected, say this hit react front light 3 was selected, then I could write a value out, as well as choosers always return an asset, but output columns can additionally write output values to a struct or to a member in the blueprint so I could write something out to my damage reaction demo ABP. But in this case, when you're using the chooser player node, that comes with a struct that is built as a code-defined struct, and you can write values in there that the chooser player will use to control how it plays back the animation. So for example, I could set the blend time on this animation to 1, then the rest of them would blend instantly, and this one would blend for 1 second. So that's output columns, and we have a few different kinds of output columns, including one that will write a struct. So you can basically write out anything using that. However, you do have to have a primary output that's a U object. And I also have a couple more things to mention. Non-animation choosers. I've been demoing this with a chooser that's selecting animation sequences, but the system isn't really tied tightly to animations. The thing that I just showed where it's using the chooser player node in an anim graph, that's an animation specific feature, but we also have a blueprint node that will just evaluate a chooser and return the asset. And so, for example, down here, I can actually show you this demo. By the way, also these examples are all in the content examples project. Even in 5.4. This is an example that spawns a tree. It takes a long time to load the textures. And it spawns a different tree depending on whether or not I flip the switch. So that's using an asset that's completely unrelated to animation. And you can imagine using it for montages for animations. You could use it for VFX or audio. So while this talk is primarily targeted at animators, and our group that built this tech built it primarily for animators, it's very useful for all kinds of assets. I think that's all the features I wanted to talk about. And as I mentioned, there's this test suite in the content examples project in the choosers level, or animation choosers, I believe it's called. I've duplicated it here, so it's called demo level here. But and that example shows off a whole bunch of the different features independently. So we're using choosers all over the place now. We, like a lot of our other tech, we're dogfooding it on our own internal projects, including Battle Royale, Lego Fortnite, and as well as the gameplay animation sample, which uses it quite a bit as well. So Patty's going to go on to talk about the game animation sample and what kind of new stuff is coming up there in 5.5. Let me just stop this so it doesn't use all your CPU.
Thank you, Keith. And then everyone clap. I'm just going to close Keith's stuff for now. Yes. So hopefully we really just wanted everyone to know about choosers. I think it's super, super useful across the board for everybody. It's such sort of a staple tool, and I think it will really speed up a lot of people's workflow. So thanks for coming and checking it out. Definitely give it a shot and let us know what you think. So what's new for gameplay animation in 5.5? So keep in mind, everything I show here is a earlier cut of 5.5. None of this is done. And so when it crashes, I will weep sadly, and that will also take up extra time. Also, good job on 30 minutes. Well done. Okay, so first thing I'm going to start with here is arbitrary curves and motion matching. So motion matching, if you're not aware, takes in a bunch of channel data, and then relative to that and input, we select things relative to it. We've been mainly using it for locomotion, but by allowing us to put in arbitrary curves or float data, you can sort of, anything that you can represent as a curve, you can then select using motion matching relative to it. Now, this is not the world's greatest example, but of course I've got pants. I didn't want pants. I wanted at least face. So here I've got this animation clip, and it's got a whole bunch of, actually I don't think this animation clip has any facial data on it, so that was kind of useless. But the point here that you're trying to see is I've got a bunch of facial curves that are being written out, so usually for like blend space or blend shapes or whatnot. So these curves are, yeah, you know, like wrinkle, upper, so forth. So what I've done here, I've got this little, and I actually have a real face here. Look at this. Okay, camera, calm it down. So what I'm doing is in motion meshing, I am actually taking a look at one of those facial curves. And where am I here? Oh, wow, I did not remember the curve. That's so bad for me right now. Okay, one
Why
sec.
don't you go into the database? And
I'm gonna sort it out, but it's, you know, I did this already, and now I have to do it again. It's gonna pad some time. That's good. This is the facial curve that I was trying to do. So we're gonna copy that, and I'm gonna go back here, and I'm going to feed that into here. Okay, so now I can drive motion matching via that curve. Like I said, this isn't the world's greatest example, but you can imagine that now I can essentially, if I had a bunch of facial shapes and I wanted to feed that through motion matching, and then I had a curve that represented, I don't know, some line of dialogue or something like that, and I needed to sync those two curves up together, you could, in theory, have motion matching do a sort of, I mean, we have systems that does this. That's why this isn't the world's greatest example. But what's cool about this, and I'm going to show another example of that, is that this allowed us to write an anim modifier that got us the phase of all of our animations. And then now I can feed that into motion matching, and now I can motion match based on the phase. Another one that we've done in the past is you can imagine you have body gestures, right? Like characters talking to each other. You go up to an NPC and they're talking to you. You can imagine that I could create an intensity of those gestures that I'm doing, and then you could feed in an intensity of a dialogue. If you offset those two things, now motion matching can sort of build a performance relative to that. What's cool about this is that it opens up motion matching to many more things beyond just locomotion. Although I am now going to talk more about locomotion. Well, I will after this. But this is sort of an additional feature that we added. We're going to be using this for a bunch of future tech as well. So there'll be more examples coming in future releases. So it's sort of just the beginning, but it is very, very cool. And I highly recommend you start thinking about different ways that you could use this, because now you can represent all kinds of data and pipe it into motion matching. And I believe this is also, it pipes into, oh no, the phase one does. You can also pipe it into the pose history node as well. So that's arbitrary curves. Right, rewind debugger. So rewind debugger is great, and wow, sequencer, never open that. One sec. All my windows are all messed up. There we go. So, you know, we've had, I actually need to, select the character so that I can actually see something. We've had rewind debugger, I think working quite well since 5.4. Keith's done a whole bunch of fixes for 5.5. One of the cool additions I think that we've added is that you can now run a character around. And we actually use this internally for our development. Like when QA's running around and trying to help us out, figure out why we broke everything, they can actually save out the input of what the character is doing and send us a file and say, hey, look, on frame 677, the whole pose blows up for X reason. So you can save and load the trace files now. Oh, I've forgotten everything. Yay! Yeah, there we go. Yeah, see, actually, was that the right one?
That's
maybe.
Definitely the right one.
Oh, yeah, okay. Oh, no. I knew it. I knew I was going to do it. I hit the wrong button. I'm so sorry, everybody. Keith said you were going to do this, and I'm like, no, I won't, and then I did it. I'm going to load it again. You don't want to play the simulation again. You want to play rewind debugger. So this is something I did, I don't know, 2 days ago. So, like I said, I'm not doing anything. It's just replaying a saved load that we had of something. This is super, super useful. It really, really helps, especially in QA, but it can also help validate. You can imagine that if I'm in motion matching and I want to tune a bunch of things, I can rerun it through something that looked great, or maybe there was an area you didn't like and you just want to make sure that it does it again to see if it solved that problem for you. So there's a lot of use cases for that. And then finally, again, I told you, mostly choosers, little sprinkle here for you guys. The final one that I wanted to talk about, and unfortunately, we lost the example at the very end because of a bug, and I'm so sorry. But I'm going to talk about it, and talking about it will be good enough. There is a attribute-based root motion component now. So root motion inside of the engine has been not great forever. So if you are aware of how root motion works inside of the engine, there is a sort of enum. It's like a drop down, and there's like root motion on everything, root motion on montages only, ignore root motion, and then there's one other one that I don't remember.
None.
None is the edge is none.
I can talk about this one, Patty. Yeah, so if you're familiar with how root motion from everything, for example, works, is one, it makes your game super slow because it forces the update to be in the game loop in the main thread. And two, it doesn't really blend animations together the way that they are blended together through the graph. It uses the overall blend weight, which is kind of the same thing that we use to control sync group syncing. And then it blends them together linearly based on that weight. And that's not even the same way that they blend through the graph. So quite a while ago now, we added the root motion attribute, which does blend through the graph. And until recently, we'd mainly been using it for things like orientation warping, basically procedural ways in which we're changing the rest of the pose procedurally. But now we're starting to move towards a world where that attribute can be used for actual root motion. And we've got an experimental component called attribute-based root motion, which will use the output root motion attribute from the previous frame to drive physics for the next frame. That means you're getting a frame of lag, which is obviously not ideal. This is still experimental, work in progress, but though you're getting a frame of lag, you're getting the proper blend through the graph, and you're not paying the cost of moving all your game animation update to the game thread. Also, there's another feature that we have that's called offset root bone that you might be familiar with, and you can use that to sort of fake the current frame's root motion without any physics collision so that you don't actually see the frame of lag. So that's just, I guess, a preview of where we're headed with root motion. We will be eventually getting to a world where we don't have to have that frame of lag. But there's been a lot of studios wishing they had any way to easily enable root motion that just blends through the graph like everything else, particularly for single player experiences. So that is there now to play with if you're interested.
Yep, and definitely one thing that we want to get to is to a point where it's just a tool, right? That you just say, I want to use root motion here, or I don't want to use root motion here, and it just works. And so we are working very heavily on this. Yeah, we should, again, expect some updates in 5.5, but definitely future updates are going to have this, A, production ready, and then B, solved. Okay, I'm going to go back here just so that I can do this. Look at that. You got to see that. Okay, so I'm going to literally just go right back to the thing that we were just looking at. But now I'm going to talk a bit about the game anim sample, which is the thing that you have been looking at here. So you can probably tell that it's not changed a ton from 5.4. Part of the reason for that, of course, is that we released 5.4 in the middle of 5.4. But that doesn't mean we didn't do anything. There's a couple of things. So one thing that we heard a lot of was that you need a ton of data for motion matching to work. And we did try to sort of mitigate that by having the sparse setup to show people that you don't need a ton of data. But I don't think that we really got the message across entirely. So you don't need a ton of data to get motion matching working. The reason that we gave out 500 plus animations was that we wanted to just give everybody tons of data to play with so that they could pick and choose how much of that data they cared about to use in their game. So with that, we also heard that people would say things like, well, oh, that's the wrong thing. You'd use motion matching over a state machine, as an example. But to me, all the tools are just tools that you can choose how you want to use them and you don't want to use them. So one of the things that we wanted to do to prove that out was a technical animator on my team, Caleb, who many people know as the person who did ALS. He decided he was going to use a state machine, choosers, and motion matching all together, sort of in harmony, and create a setup that isn't just using motion matching the way that we've been doing traditionally, but showing that you can use all the tools in harmony and they can just work together. I'm going to close these two now. So that is this little section here that is going to be released with 5.5. It is still experimental, but it's a really cool setup. It's a little bit too complicated, and what I mean by that is that, and I'm going to show you, there's a function that has a bunch of extra work. I want us to really look at these kinds of things and simplify those things down, but that's why we do this. So the state machine itself is actually just a logic state machine. It is not outputting any pose. What it is determining is just, what am I doing? When you're in locomotion, either you're in a loop, you're in a transition to a loop, or you're in some state that you need to move between those two things quickly. That's basically what this is. This is just and he had it for jumping, not on ground and then on ground as well. So this is just a logical state machine. It does not output any pose. And then if we go back here, we've got the blend stack. So the blend stack is part of motion matching, but you can use it on its own. It is just a stack of blends. Essentially, you push in different assets and it blends those assets together however you want them to be blended. So when we go inside of here, the blend stack also contains most of our procedural systems. So like the steering node, orientation warping. The reason for this is that it needs to know that when it's blending these things together, which is why we've been putting them inside of that. And then, let's see here. Here's the function for this. Sorry, I had all these things open and then I lost it.
One of the reasons he's using that state machine and a blend stack instead of a state machine that actually has poses in it is that this setup allows reentrancy. So with a regular state machine, you can't ping pong between states in this setup because the states are simply logical and they trigger the blend stack to blend into a particular state that allows reentrancy.
So this is the piece I said that I think is a little too complicated. And this is just more on our end. We need to figure out a way to simplify these things for new users specifically as well. It's not that there's anything wrong. This is how most devs use Unreal in these kinds of ways. But for me, I think that we can make these things a bit simpler. But essentially what he's doing is he's updating the state machine state and then storing that. We're grabbing assets from a chooser, checking whether they're valid or not, getting those outputs, and then we're sort of setting these into a bunch of inputs that then go into the blend stack. That's the sort of general. I know I'm skipping over some things, but for time and also just to not go through all of the things. And then we've got this chooser. So again, choosers, yay. The entirety of the state machine setup is using the chooser. So the state machine is basically just telling the chooser what to do. Sorry, I've got my resolution at 1.5 so you guys can actually see something, but obviously it's hard to. So at the very top here, and these are all nested choosers, we've got the state machine state, the stance, whether I'm standing or I'm crouched, and then the gait, which is obviously walk, run, sprint. And then inside of these different ones, we have more. We go again to the state machine state, the speed of the character, and then Keith talked a bit about the output struct. I think this is one of the cool parts of this as well. So what this is doing is Caleb has it set up so that you can essentially output whether you want the state to be mirrored, what its start time is, does it use motion matching? Now, when I say use motion matching, what it's doing is it goes into the chooser, and you can tag up sections of all of your assets and say, hey, when I go into this, just pick whatever the best frame relative to this thing is. So it's not really bucketing them all into one big database. It's just looking at little pieces of those and saying, hey, give me the best frame. Match the phase, match the feet. Then we can also limit the cost. So if the cost is bad, we bail out of that one. And then we can also set the blend time. So you have full control over every single blend of every single asset inside of here and the profile. And then if you want to add some extra tags to it. So when we first did this, and we've got it on a little switch here, I wasn't sure what to expect because it's using significantly less data. So what you were seeing there, sorry, again, in the chooser, like that is a single asset. In the stops, he's got some of them, but not a ton. It's mostly like this. He's not using all the pivots, all of the sort of data. He's relying very heavily on steering and orientation warping. It basically feels exactly the same. So this is using the state machine setup that I was talking about. I know that it's kind of hard because it just looks exactly the same as the big motion matching setup. But the point here is he even got like all of the shuffle steps for the change in directions to work. We can switch to the different speeds. We've got a new sprint state, which I'm going to talk about shortly, just a little bit. And yeah, we were pretty impressed. I would highly recommend people take a look at this, especially if you are looking to reduce the amount of data, but also to see how all of the different tools themselves can sort of work together. Because I think that is sort of a big piece of that. Oops, sorry, I have this thing where I always alt-tab to pause. Another thing I want to talk about, just briefly, because I think it's really cool, but it's very experimental, is we have a new gameplay camera system. So this is something that, animation, shaders, audio, they all have their own graph-based systems, and cameras have never really had that. Most people roll their own. But now we do. And I think it's the beginning of something, but the camera to gameplay is so important. Having a bad camera kills all of your animation. It is a character within your world as you're building a game, so it needs to have that same level of control and work with. So we have a new character sort of director. You can create your own subset of sort of character or camera rigs. So in this instance, it's actually just a bunch of offsets. So you can see we've got balanced aim, there's the free cam strafe, loose, tight. And then inside of this, it's all the same, whoops. Oh no, that is what I wanted. So inside of here, you can see that you've got a toolbox of sort of different pieces that you can use for your camera. There's post-processing, offsets, the usual ones, boom arm, dampen, offset, field of vision. You can even put in animations, blueprint, all kinds of different pieces. And you can combine them all together, and it creates this sort of awesome camera setup. So what we wanted to do for 5.5 is we replaced the entire, so we had a big blueprint for the cameras that Caleb had put together. We replaced it entirely, and now it's all running off of the new gameplay camera system. So I think what we want from you guys for this is check it out, try it out, give us feedback, tell us what you want from this. Ludo is the engineer who has been working on this, and he has a lot of experience building camera systems in video games and in engines. So he's really, really excited. We wanted to get the message out, and I think it's going to be really awesome. So I highly, highly, highly recommend you check that out. Nope, doing it again. Okay, foot placement. This is another one where it's like, how did we not have this? We've never really had a good foot planning system. Now, Control Rig is amazing, obviously, and you can roll your own with Control Rig. That's one of the best things about Control Rig is that it gives you all the pieces and you can create your own. But it's almost kind of like a staple, right? Like, we should have an out-of-the-box thing that can handle foot placement. So we do in 5.5, and foot placement has existed in the engine for a few releases, but it's been pretty buggy and it's had some issues. We've really spent some time to track down a lot of that and get a stable experimental release of it, where we felt it was worth putting into the game anim sample. So now we have a full foot planting system. So what you're seeing here in the debug is sort of a range. You can see when it's red, you got those little boxes on its feet. Those when it's planting. The ranges are sort of the area of error that we're going to allow the feet to be within the pose. And then, of course, that sort of outer one is the overall range of error that you can do. So part of this, of course, is uneven terrain. So it handles all of the trace for that. It has overridable settings. So you can create structs and you can change the settings. So how it works basically is that, dang it. I'm never going to get past that. I'm so sorry. I need to grab a animation. Let's grab a run. Sure. So we have these two curves. We have foot speed L and foot speed R. And that's sort of the main thing. We need to understand how fast are the feet moving. We have a anim modifier that you can use out of the box. You just add these, hit apply, auto-generates it for you. And then you pipe that into the foot placement node, which is right here. And you can see we've got the plant settings on an actual variable so that you can adjust these. So I think one of the things that we tested early was just we wanted different settings for when you were moving than when you were coming to a stop, which is probably the most common use case of when you're coming to a stop, you don't want it to kind of get into weird spots where the foot planting kind of plants your feet off. Although, as a part of this, we do have a sort of procedural weight recalibration. It's not really the right word, but you can imagine that if I'm gonna step over here. If I come to a stop and I somehow end up like this, and my animated position of my hips might be over here because this was probably where I wanted it to be, and it's really hard for me to do this without falling over. What would happen is that my hips would be over here, and then this would be like this, and I would look really, really weird. So what it does is it looks at the feet, and then it essentially finds the midpoint of where your weight should be, and it auto-adjusts the hips. You can tune this where how much you want it to let it do that, or at all if you want. But the idea being that if you want to give it a little bit of room, you can, and it will still look quite good. 7 minutes, damn.
That's a lot of time.
I know. Holy crap, I'm going to speed up. So that's awesome. Check it out. Now I have to go fast. I think actually probably the next one is the most asked for thing. The entire sample with motion matching is networked. So yay! I know we shipped it in 5.4. We were going quick to try and get it out, and it wasn't networked. So now, this is probably the riskiest thing I'm going to do in this live demo. We can set it to 2, and I can place client. Move this one over there. Sorry, the multiple. Oh. Hold on, I'm getting my bearings over here because I have it on a different screen. So this character is now fully networked. Oh my God, look at that. I know it's like not that crazy, but it's good. Yay! This obviously was massive for us. We knew when we shipped it in 5.4 that this was a big missing piece. So apologies for the delay, but you can check it out. It's all completely networked. And of course, I know that lots of people kickstart some of their projects with this. So now you can kickstart it and it's networked, which is pretty good. Okay, so finally, I had said that we had extra animations. So we shipped with about 500 animations. We are adding just over 300 more. So those 300 aren't super exciting. So I'm going to explain this because I think this is another thing that's kind of come out. So we're adding a bunch of sprint animations. We're adding a ton of crouch animations, a full set, and then we're adding the rest of what we needed for the walk set. It's a bit overkill, I know that. But the reason that we're doing this is we want to have all of the foundational locomotion animations done, because everything builds off of that. So the reason that we wanted to sort of fill all that out is that now all the future releases, we're going to start looking into all of the really, really fun stuff. We will get to things like cover systems. We will get to things like climbing systems. We will get to things like combat and other more interesting things. And we will be releasing all of this for free. We are going to continue building upon this. But for this one, we wanted to just flesh out the remainder of the locomotion set so that we had that foundation sort of built out. So it's still 300 free animations. So, I mean, you can't complain that bad. But I just wanted to call that out. I think, it'll be good. You guys are going to like it. Use as much as you want. Figure out what's right for you, how much data you want to use. And like I said, give us feedback. Okay. Wow, it didn't crash. Look at us. I'm just joking. We knew it was going to crash. Okay, so with 4 minutes left, I'm so sorry. We're going to just take a really quick look at what we're going to be taking a look at in the near future. I know this is something that everybody asks about, so where are you guys going? So easy extracting game trajectories for matching animations. So this is tough, right? You've got motion matching, you've got whatever you have set up your game pathing and your movement model to be. And now you gotta figure out how do I match that to my animations? As part of Rewind Debugger, we are creating a tool that will allow you to just grab a section of Rewind Debugger, select a character, and then you can either output what the trajectory of it was, you can output the whole pose of it. We want to make it really, really easy for you to get that data, whether you're going to do Animate Engine, which you should, or if you want to bring it out to another DCC package, which you can also do. We're going to sort of support that. Layering improvements and focus. So when I say layering, I mean gameplay animation layering. I mean, I want to play something on the upper body. I want to hold a weapon while I have a underlying base animation set. Right now, it's all through Blueprint. It's a bit cumbersome. You get these really big graphs of trying to sort of layer things on. One of the things that I personally have been really pushing our teams to do is to get everything to be artist-focused. So I want to make a very artist-focused UX and look with a ton of different features, because layering is one of the most important things that you have when you're building a video game. So that will be coming in the hopefully near-ish future. Choosers in the motion matching database. So right now we saw you have choosers. You can use it to pick the different databases. Well, we want to kind of put the choosers in the actual database itself and to let you select at the asset level inside of the databases. I think once you have that, you kind of have everything that you need at that point, because now you can filter all of the data as a second step inside of it. So if you have certain things that you just want to not search against, it's a lot easier than having to bucket it all into a bunch of different motion matching databases. The animation state machine is another tool that is good but slightly rough. And we've been going back and forth. A lot of the engine has been moving to a more state tree setup. What I don't want to do is remove anything that is good about the state machine. What I want to do is I want to take the concept of the state machine and infuse it with the good pieces of a state tree. But like I said, keep a very animator and artist-focused UX against the entire thing. Another one like layering, the state machine is so vital, I think, to building animation inside of your games. And then, of course, Keith has to figure out how to network promotion.
No problem.
Yeah, he's got it. And that's it. Thank you so much.